So don't go to the classroom. Hopefully you all got that message. I'm not doing any face-to-face classes until I stop testing positive for COVID. I tested positive again today. I'll probably clear up by next week or so, but we'll see. Anyway, so this is 121, and we are down here to Module 10, Mobile App Investigation. So let's start with that, which is here. All right. So when you want to analyze a mobile app, I've done hundreds of these. There are two ways to do it. One is to do static analysis, where you look at the raw code, the source code or the compiled code or whatever code you have, and analyze it to figure out how it works. That is quite difficult. What's much easier usually is dynamic analysis. However, one thing you can do in the way of static analysis is you can look at the database that was stored. Most mobile apps store data in SQLite databases, a single file database like this. And these things are in a sort of binary format to some extent. Quite a bit of it is readable strings, but there are some binary markers and such. And so you typically get a SQLite viewing app to look inside there. And you download this single file, you can open it, and in there there'll be the information like here's Tinder, so it'll store the information that the Tinder dating app has stored. So in iOS, you'll find it in the library folder, library application support, the name of the application. In Android, it'll be in the data folder, as we talked about before. There's subfolders in the data folder that are similar. And the other thing you can do is you can analyze the code. Now, most of the code is instructions that are sort of hard to read and hard to understand, but parts of it are easy. And one thing in Android they point out is the Android manifest. Every app has an Android manifest XML file, and this shows the general permissions and settings for the application. And so down towards the bottom of it, you will just see a list of all the permissions it has: access, course and find location, network state, Wi-Fi state, and so on. Bluetooth. These are the parts of the phone that this app is allowed to access. And this refers to the GPS location and Wi-Fi and so on. So that's one thing you can see is what permissions an app has. And if you want to analyze the source code further, one good tool is Dex2Jar. Another one is JADX GUI, which will take an Android app and decompile it back to Java, so you can read the Java source code. It's really quite nice. And Android apps are very easy to reverse engineer because they're distributed in a form that is very close to just giving you the source code for every app. You do not really need to read compiled binary code. And then an even easier thing to do is dynamic analysis. You just run the app and then you measure the effect it has on other parts of it. You can, one thing you can do, for example, is just monitor the network traffic by picking it up at the proxy or at the router or on the device one way or another. And so you pick up the packets it sends. And so here is an app that uses Google Maps, and here it is sending a API request to maps.googleapis.com. So like many apps, it has some kind of map, and you can drag it around or something, and here's some of the requests used to update the map. So that's another thing you can do. And they showed, for example, if you use Tinder, Tinder connects social media accounts within the app. And so you can see all the domains associated with Tinder. So here you've got an Amazon website going to more Amazon websites, going to Massachusetts Institute of Technology, and so on. So you can see the various domains it passes through. And Robtex is a tool you can use to analyze the network traffic from things like IP addresses and get them down to the name of companies and such. And that's usually interesting primarily for malware, to find out what country it's from, where's the malicious server, and so on. You can determine where the app is being stored, and therefore, if you were a police agency, if you find out what country it's being stored in, you can decide whether you can get a search warrant for it from jurisdiction. So that's another issue. All right, and here's Tinder's SQLite database, and that shows the distance to other nearby Tinder users. So that is information that when people found out Tinder did this, they were sort of concerned about the privacy implications. You could sort of use this data to track down where people are and stalk them and such. But anyway, it's in there, and you can also get more precise information about them. New York. I'm not sure how precise it is, though. Just looks like, oh, giving you latitude and longitude to a couple decimal places. So that's pretty close. All right. And then Skype has a SQLite database, and it's got all kinds of data in there. Just another example, like contacts and videos and participants, chats, messages, and so on. As you expect, every app has all kinds of data in it. And you saw this from doing the mobile app analysis that we've done on Android, and I think iOS, we've already done those in the projects. So let's go down to the next bit, which is image forensics. So images are extremely valuable. One great thing about an image is it's very easy to explain to a judge and a jury what an image shows, whereas some table full of technical binary might be more of a problem, but anybody can usually see what an image is. Here is the suspect doing the bad thing right here. So if you have so-called innocent images, these are child exploitation images, images of children being exploited, which is a huge law enforcement priority because a lot of these children are kidnapped and they used to make these videos and then killed, and it's a huge issue, and parents get very upset, as you can imagine. And so it's a huge desire to do something about this, and there are extreme legal punishments for possession of this stuff. So if you ever come across any of these child porn images, you have to immediately contact the National Center for Missing and Exploited Children and pass it up to them. There's also a Project Vic, is a collaboration between law enforcement and international law enforcement to try to rescue child abuse victims. So there's these different projects out there. You can use the hash of a photo to identify it without having to view the images, which is greatly recommended because it upsets people a lot to have to look at these things. And Project Vic can quickly identify victims using a thing called PhotoDNA, which is a sort of hash value sort of images. And there are other projects where I know there's a project where they analyze all the pictures of hotel rooms to figure out where they are to capture people who are being sex trafficked. Anyway, so Facebook selfies. Here was a woman who pled guilty to killing her friend in March 2015 because there was a belt found near the body, and that was a match to a belt that the attacker had worn in a selfie posted on Facebook. So she wore this belt, posed and took a picture on Facebook, and then used the belt to strangle somebody and left it behind at the scene. So this is the same kind of thing that's happened to a whole lot of the people who invaded the Capitol on January 6th. The FBI seems to have been relatively helpless and incompetent in investigating it, but a whole lot of amateurs have analyzed videos on Twitter and so on and tracked down who people are and where they are and handed off this evidence to the FBI to sort of prod them into doing something. I read an article trying to explain why the FBI was so extremely ineffective, and they said one thing they say about the FBI, which is true of most of the government, is we have yesterday's technology tomorrow. Their technology is very primitive, their technical skills are very primitive, they say, and they're not able to do as good a job as amateurs at hunting through this stuff. It's certainly the case that government is very bureaucratic and very backward on technological issues in most cases. And then there was this To Catch a Predator. There was a child predator that took pictures of himself, and using special technology, a special agent, sounded like an FBI special agent, was able to identify a prescription medication bottle in a photo. He was able to get the first name and 2 letters of the last name, along with some digits of the prescription number, and that was enough to track down who the person was. This is quite common. People take a photograph of something to put on eBay or somewhere, and they don't realize that a reflection in a window or in a shiny object or something in the background can be used to find you. I know one thing my sister does, she plays a game online. It's a fairly popular game where they just post a photograph somebody takes like out the window at a hotel, showing like the corner of a building and a tree. And people will try to figure out where that photo is, and people that learn how to do it are very good at this. They can take a picture of anything anywhere, and they can track down exactly where it came from by using a variety of tools and techniques. So, and then of course extortion. This is a really big deal. People call these victims their slaves. They get teenagers typically, and they trick them into sending them a nude picture or something, and then they say, if you don't send me more nude pictures, I'll show this to your parents and your teacher and your church and everybody, and out of the shame they're able to control them and get them to send them more and more stuff. And this is a really big crime. Here they mentioned 6 months in jail and a $1,000 fine. I think you can get much larger punishments than that, and it's also very damaging to the children, as you would imagine. So, but it is a pretty common thing. And this one's talking about revenge porn, which is that's why it's just lesser punishment. Revenge porn is where you take pictures that someone gave you, naked pictures, willingly, but without the intent of them being posted, and then you post them online. Yeah, GeoGuessr. That might be it. Yeah. I don't know the name. I know there's more than one of them, but that's one my sister does. She's good at it. I haven't tried it yet. But anyway, so digital photography from a technical point of view. You take a photograph, there's a light-sensitive semiconductor in the camera that takes a bunch of pixels and stores them in computer files. And so you can store them on SSDs or SD cards or climate flash or anything like that, and in a file system of typically FAT or exFAT. All right, and often you have DKIM folders, which is the root directory in a digital camera, the standard protocol for digital cameras. So we'll talk more about these file types coming up. Anyway, so social media like Snapchat and the one from Meta, everybody puts the images on it. I forget the name of it because I don't use it. But anyway, these huge repositories of photo images, and they can be incriminating. Especially since they often have information people didn't really intend to put in them, like GPS coordinates. So Facebook, for example, was able to identify 18 billion faces, and for one time Facebook was indexing all the faces, so you would put the names on every thumb of your picture, and it would find all the others with AI and label them, so people's confidentiality was exposed, and a third-party company did that to an extreme extent. So Flickr has a bunch of photos. Instagram, that's it. Instagram is the main one, has tons of photos. And Snapchat. Now, Snapchat was supposed to improve your privacy by promising you that the photos will vanish after a few seconds, so they're not up there forever like Instagram to make trouble for you later. But that turned out, of course, not to be true because, for one thing, someone could just take a photograph of the screen or a screenshot of the screen, and then they'd have it. And another thing is that they didn't really erase the files as much as they said they would. And images taken are still present on the user's device. So it turns out that Snapchat's claim that these things would vanish and you don't have to worry about the privacy implications was exaggerated. So anyway, picture files. EXIF is the metadata associated with digital pictures, and most smart devices like smartphones will take a picture and it will automatically add a bunch of other data, such as the date, the particular make of the camera, the shutter speed, latitude and longitude, and the EXIF data therefore has a lot of extra information that's quite useful. It, by the way, is not particularly reliable. It's not verified by signature or hash or anything, so you could manipulate the EXIF data. You could change that if you wanted to, so it appears to come from a different latitude and longitude. But the most common situation, of course, is people take pictures of things and they don't realize that it's got the latitude and longitude in it, and they put it up and it's accurate. That's how they caught a lot of people, including John McAfee. John McAfee was on the run, and they caught him from a photograph taken by a journalist to put in a Vice article that had his latitude and longitude in them. So a raster graphic is what all these are, a grid of pixels, just the color and brightness of all these dots in a rectangular image. That's what a picture really is, and you can store that in various ways. A raw image or a bitmap image just stores those pixels one by one in the simplest data. That makes the file very large, and therefore these are not very commonly used. These other image formats are greatly preferred because they compress the image to make the file much smaller, like JPEG, PNG, GIF, and TIFF. JPEG can compress to be very small, but JPEG is a lossy compression. It stands for Joint Photographic Experts Group, and they attempted to take real measurements of human visual perception and carefully remove the details of an image that a human could not notice to make it as small as possible without affecting the picture quality. So it's quite popular. Bitmap is the Windows raw storage format, which is uncompressed and therefore very large and typically only used for little tiny things like these little icons up here. These little things up here are called favicons, the little thing that comes, this thing here. And the little tiny images like that are often bitmaps, but anything large is typically not a bitmap because it would be a very large file size. PNG is lossless compression and often used on the internet. GIF also uses a lossless compression algorithm, although GIFs are limited to only 256 colors, so they're not generally good for photographs, but they're used for things like cartoons and logos. TIFF is another format that you see, and it seems to be lossless compression, and I think it has full support for colors, although I'm not quite sure. Anyway, in Windows systems and also on Macs, if you store photographs on there, it also stores a thumbnail, shrunken image of the photograph, just to show you when you're looking at a folder full of files. And those thumbnails are sometimes preserved and even when a file is deleted, so sometimes you can find useful things there. And a vector graphic is another form of graphic that is not a series of brightness values. In a grid, it is just a mathematical description. Draw a circle of this radius centered here, and then draw a line here and a line here. So for things like logos that are composed of arcs and line segments, it can be much smaller. And the thing about that is it remains high quality at every size. You can zoom in, and it stays high quality because it recalculates the mathematical lines. So those are vector graphics, and SVG is the most common format of scalable vector graphics. That's the main form you see. So there's an original document rule, which says you should have the original document to take to court. But of course, computer documents often don't have a material format in the first place, so you can use a duplicate if it's deemed a genuine copy or one that's unaltered. So a printout is regarded as an original. All right, digital photos, you can do a lot to improve the clarity. You can do brightness adjustment, cropping, color balancing, and with AI, you can even de-blur noise and such and so on. You can do lots of things. For example, here's a criminal who posted a picture, and he smeared his face with something like Photoshop, where you smear the tool. But since this is not really covering it with black stuff to blot it out or randomizing, it's systematic. They were able to reverse that process. As you can imagine, this looks like it's just a systematic rotation of one or two turns. And so you could just mathematically reverse it, and they were able to mathematically reverse it and get an accurate enough picture to catch the criminal. All right. Well, that's it for this discussion. Let's try a Kahoot. It is Chapter 10, Mod 10 here. I don't quite get it why photos can be reversed after being altered. Well, if the alteration is systematic, then it's a mathematical transformation like that is. If you just take all the pixels and rotate them around in a circle, then you can just rotate them back. You know, that's all. Like I say, if you randomly scrambled the image, it might be hard to reverse. But if you do something like that, where you just sort of smear things in a circle, then you can just unsmear them. Because it's just taken the colored dots and moved them around. So all I have to do is put them back where they were. Same thing happens with the cryptography, by the way. There are cryptographic systems like this, where you just rearrange the letters without changing them. And so all you have to do is rearrange the letters back to their original position to break it. That's all. Evidently, the crook thought that was enough to obscure his face completely, but it was wrong about that. If he just covered his face with like a black circle, removing all the pixels, that would have been irreversible. Unless it was a PDF, in which case the black cover on top would just be an extra object and the thing underneath would still be there. So that's why you have to know a little about what you're doing when you try to redact documents. It's a fairly common situation that people try to redact PDFs or Word documents and they don't realize that the original text is still there. Why can't the same thing be done for encryption? It can. Weak forms of encryption can be reversed by such simple techniques. Stronger forms like AES are carefully designed to prevent that. Very good question. Why there are encryption techniques like the real French cipher that just rearrange the letters, and those can be reversed pretty easily. All right, let's try this Kahoot. All right, so a technology used to store data in mobile apps. All right, that's SQLite. Good. All right, so what organization includes both private and law enforcement parties working together? Pushed these public-private partnerships a lot a few years ago. Heard a lot about them. I don't hear that much about them now. Project Vic. All right. So what company made misleading claims that the images would vanish quickly? And that was Snapchat. And of course, the images do vanish more quickly than what you'd see on like the image hosting websites like Instagram that stay up there forever. So that's why whenever you make a claim about privacy or security, you have to not let your marketing department get carried away and make a careful statement, because nothing is perfectly private and nothing is perfectly secure. And yet you can have things that do offer some increased level of privacy or security. And if they'd made a careful statement like that, they probably would have been okay. All right, and which is a lossy image format? Yeah, JPEG degrades the image as it compresses it, so you can make it much smaller if you're willing to let it get distorted. All right, JVD. E40. Well, I don't think my grader will know who you are. If you want your points, you'll have to tell us. And TAT. I know who that is, however. All right, good. So I'm going to stop this recording.